Lynnelle Ye.
Okay, hi everyone. So what I want to talk about today is math education from the perspective of someone who's made math the focal point of her academic life for the past few years. And specifically what I want to talk about is public school math education, just because that topic is so very good for starting arguments. So now obviously my perspective on this topic has serious limitations. Before coming to Stanford, I went through the Palo Alto Unified School District, PAUSD, K through 12, so I've been extremely fortunate in my public school experience, and I can't really speak to districts other than Palo Alto districts that are possibly not as competitive or well-funded. So instead of talking about public school math education as it is, because I'm really too ignorant to do that, I want to talk about public school math education, or the theory behind it, as it should be. And fortunately for me, this topic is sufficiently vague and philosophical that I don't have to sound ridiculous, but it's also contentious enough to inspire ferocious debate. So what's my theory about math education? My theory is that I believe places like PAUSD already approximate to some extent the things that can be done. And this is a really boring theory, because basically what I'm saying is that I don't think we need to innovate. I think that if Palo Alto ever takes over the world, I'll be perfectly happy with the state of math education in human society. So I might sound a lot less boring if I weren't defending the status quo. Usually when people talk about education in the media, it's a lot of how screwed up it is, and how it needs to be radically reformed, and all these new experiments in education and things like that. And the truth is, there are all kinds of things that I didn't like about my experiences with math education in the PAUSD, but I think it would be extremely boring for me to go on a rant about how much math everyone should know and understand in my ideal world. Like, that would just be silly. So instead, I want to focus on the good parts. Specifically, I want to focus on the parts that I think are good, that a lot of people I know disagree with. And this might mean that I end up saying a lot of really obvious things, so I apologize if it's boring, but I think that these are obvious things that need to be said because they cause confusion. So even among my fellow math nerds, especially among my fellow math nerds, there are a lot of people who reject not just a specific implementation of a specific math curriculum in a specific district, but the very idea of teaching math in a form remotely recognizable as what we're doing now. And they say this thing constantly, even some of my fellow math nerds. And the thing is this: why bother teaching math? Most people will never use what they learn in math class. Most people will walk out of their final exams and allow those sines and cosines to drift out of their head and never have to let them back in. So teaching math just makes people hate math. So why bother? The few of us who like it or need it will learn it on our own, and so let's not force it on anyone. Let's give up. Now, it seems to me that people almost always only target math for this. So, I mean, maybe I'm biased, but look, why is it more useful to learn to identify symbolism in a scarlet letter than to learn how to solve a system of linear equations? And why is it more useful to know that William Henry Harrison campaigned under the slogan of Tippecanoe and Tyler too, than to know that the derivative of e to the x is e to the x? I mean, on an absolute scale, if we compare the number of people whose careers will require quoting Hamlet to the number of people whose careers will require polynomials, I guarantee that there are more of the latter. But, of course, this is an absolutely stupid comparison. And I think this is what people get really confused about when they complain about teaching to the test, and they wonder why we insist on setting standards for learning abstract things, whether they be English or history or math. Because I didn't learn to identify symbolism in a scarlet letter because for future reference, I wanted to learn to identify symbolism in the scarlet letter. I did it as part of an ongoing project of many years to improve my general sense of the way people use the English language, of how rhetoric works and how culture works, and of all the things that are secretly going on in the world of words around me. And similarly, I didn't learn about 200-year-old campaign slogans because I might have needed them for a future job. I did it as part of an equally important ongoing project to improve my overarching understanding of the influences that pull the strings of national policies and of the world of civilizations and movements and trends. And I think that having a fundamental knowledge of and intuition for the various worlds that are swirling around you is absolutely necessary to be a good citizen and to be capable of making reasonable decisions. It's not that you need to know any one particular fact, but that you need to have experienced learning many of those facts and placing them into your picture of the universe. And okay, so how does math fit into this? What does being educated in math do for your picture of the universe? Well, I would argue that it is absolutely fundamentally necessary to pretty much all parts of the picture. So every speeding car, every stock market fluctuation, every part per million of carbon dioxide, every furniture arrangement, every highway, every carcinogen, every tax cut, X-ray, asteroid, laptop, galaxy. This world that we live in is a mathematical world. It's a mathematical universe. So it's not that you need to know specifically that 8 choose 2 is 28 to find your way around such things. It's that you need to be accustomed to thinking mathematically and to approaching the world mathematically whenever it might be useful. Because much more often, I think, than people realize, it is useful. And the only way to learn to recognize when it's useful is to do lots and lots of math, do lots of math problems. So now we're starting to bleed into a related but slightly different issue. At this point, a lot of people, including, again, a number of my fellow math nerds, and in fact, this is probably a viewpoint shared particularly among math people for some reason, say this. Okay, people need to think mathematically. Okay, we need to give them a big picture. So let's just give them the big picture. Let's have them play with puzzles, draw pretty diagrams, look for patterns. They say that the current system teaches to the test. They say that it turns students into drones, repetitively applying algorithms without understanding. So let's stop. Let's forget teaching formulas. We nerds think of math as play. Let's make it play for everyone else too. So at first, this suggestion is seductive. It's entirely true that what currently goes on in even the best math classrooms is often more blind memorization than real problem solving. But I would argue passionately that the way to teach more problem solving in math or elsewhere is not to teach fewer formulas. In order to play, you need toys to play with. In order to learn English, you must read novels like A Scarlet Letter. In order to learn history, you must learn the 200-year-old campaign slogans. And so in order to learn math, you must actually, at some point, actually multiply some matrices. So we cannot remove standards. We cannot stop demanding that students add fractions and factor quadratics and calculate circle areas. Actually, on a slight tangent, another reason we definitely have to teach the test to some extent is this. I strongly suspect that the easier we make it to drift away early from a strong mathematical track, the easier we make it for social and cultural pressures to take away girls and underrepresented minorities who might not otherwise have given up. But that's sort of a side point. The philosophical point is broader. So, for example, this summer at the China Girls Math Olympiad, I solved a problem which nobody else on the US team solved, using a method which my fellow students found to be shockingly creative. It was not the official solution. It was entirely different. So did I have a moment of inspiration? Did I have a moment of genius? No. What I'd done was I'd learned a method at training camp 3 years earlier, and I'd waited 3 years for a chance to use that method. And that was the time that I got to apply it. So, of course, it wasn't just blindly applying a formula. Making it work took effort. But the point of that story is that all interesting problem solving proceeds from a foundation much too large to discover on one's own. Problem solving ability is something that you gradually earn through hard work and practice. It is very, very fun. It really is a form of play, and it shouldn't be torture, and if it ever is torture, then we're doing something wrong. But it's not something that you can take a shortcut through. You cannot grow to see the big picture of mathematics without working through the details one by one. You have to remember formulas. You have to understand them as well, but remembering comes before understanding. And then after you understand, then you can forget. And then you can see the big picture without necessarily seeing the little details and be able to think mathematically, but not before that. Thank you.
Thank you so much.